Okay, welcome back. So we'll start. Process or phenomena that we wish to study statistically are commonly known as, they are known as what? Experiments. Fairly straightforward. So the next question, set of all possible outcomes or result of any experiment is said to be sample spaces, right? So if we have an experiment, all the possible results. For example, let's say tossing a coin, right? For tossing a coin, what will be the sample space? The sample space will be possible outcomes. What are those? Heads and tails, etc., right? So for the next question, which of the following is a random experiment? Rolling a dice. Yes, it is a random experiment. Tossing a coin is also a random experiment. Observing a number of goals in a soccer match is also a random experiment. Observe the number of phones sold by ABC store in Chennai in different years. Yes, this is also a random experiment. Let's say why these are random experiments. Let's say rolling a dice. So can we predict a rolling a dice? We know there are six possible outcomes, right? 1, 2, 3, 4, 5 and 6, but we cannot predict which of these numbers will get, right? So if we roll a dice, we can get any one of these, so it is a random experiment. What about tossing a coin? Even also in tossing a coin, we know the outcome of an experiment, that is heads or tails, but we cannot predict which will have. If we continue this experiment for a long time, the possibility is what? 1 by 2 for each of this, right? What will be? Observe the number of goals in a soccer match. Even for this, we cannot predict what will be the number of goals, right? And for the next one, and for this one, we also don't know what is the sample space. We can say, let's say sample space would be, there might be 0 goals, there might be only 1 goal, 2, 3, 4, etc., right? In some matches there might be also 10 goals, right? It might not be it might not happen, but there is still a possibility that in a match we can get a 10 goal, right? So it is an infinite set. So observe the number of phones sold by ABC store in Chennai in different years. Let's say even for this set, let's say they have sold N1, N2, N3, N4 uh, number of phones in each year. Depending upon this previous data, we can predict, we can guess this amount, but we cannot say with exact amount what will be this number, right? It might depend on various other factors also, but this is also a random experiment. We cannot say with a certainty, with 100% certainty, that the next value that we'll have will be of certain order. What about next question? In the next question, suppose there are n1 doors to enter a stadium and n2 doors to exit the same stadium. One can enter through any entry gate and exit through any exit gate only. In an experiment, let the outcomes be the gate of entry and the gate of exit. Okay. What will be the cardinality of the sample space? Okay, so they're saying, let's say we have a stadium here, I have one entry point here and have another entry point here, okay, and let's say I have an exit point here and an exit point here. So I have n1 is equal to 2 and n2 is equal to 2. Let's say if I enter from this one, and I have two possibilities, one from here and one from here, okay. So I can say this, let's say A, B, and I'll say C and D. What will be my sample space now? The sample space will be A comma C, that I am entering from A and exit from C, and I can also enter from A and exit from D. What about this? Again, I can enter from B and exit from C, and also I can enter from B and exit from D. Okay, so what will be the total, what is the cardinality of sample space now? The cardinality is 4, that is nothing but n1 into n2. What if I increase the number of gates? Again the cardinality will be what? N1 will be n1 into n2, right? So the answer is n1 into n2. So the next question, consider the experiment of possibilities of runs scored by a batsman on facing a pair of balls. How many sample points are there in the sample space when a pair of balls is faced by the batsman, assuming any run from 0 to 6 can be scored by a single ball. So for a single ball, what will be the sample space? The sample space will be a set of any number between 0 and 6, right? So 0, 1, 2, 3, 4, 5 and 6. So these are the coordinates for each ball, right? So the batsman is facing how many balls? He's facing 2 balls, right? For 2 balls, what will be the cardinality of this entire set? It has 7 number, right? The cardinality of sample space is 7 for each ball. For 2 balls, what will happen? It will be multiplied by itself. 7 into 7, that will be equal to 49, right? Moving on to the second activity, we have the subset of sample space of any experiment is termed as an event, right? Okay, use the information for the question 2, 3 and 4. In the game of cricket, one legal delivery is played by a batsman. Assume that 1 to 6 runs can be scored off the delivery. Let E1 be the event that less than 4 runs are scored. E2 be the event that an even number of runs are scored. Let E3 be the event that odd number of runs are scored. Find the following events. First, let us write down all of these different E1, E2 and E3, what is the sample space, etc., and then we can easily solve all of the questions here. So what will be the sample space? The sample space is any score between 1 and 6, right? So 1, 2, 3, 4, 5 and 6. So what about E1? E1 is nothing but event that less than 4 runs are scored, that is 1, 2 and 3. What about E2? E2 is nothing but that an even number of runs are scored. What are the even numbers here? 2, 4 and 6, right? What about E3? E3 is nothing but 1 odd numbers, right? Let the event that an odd number of runs are scored, 1, 3 and 5. Okay, so what about this E1 or E2 or E3? So or can also be interpreted as what? It can be interpreted as union of sets, right? So this can be written as E1 union E2 union E3. So that is nothing but what? So we have 1, 2, 3, 4, 5 and 6, right? So we have all the numbers. So which of, okay, I have a typo here, it has been repeated, I'm sorry for that. So we have first option as the second option as the right answer. So what about next question? E1 and E2 and E3. So it is nothing but E1 intersection E2 and intersection E3. So what is this? So we have, what is E1 intersection E2? Let's say we have 2 as common, right? So we have 2 common here. So E1, E2 and E3 is nothing but set containing 2 intersection E3. E3 is nothing but 1, 3 and 5. So we have no common elements between these two. So therefore what we'll have is a null set. Okay, this is the answer. Fourth one, E1 but not in E3, right? So this is nothing but what do we have in E1? This is nothing but difference, right? So we have 1, 2, 3 in E1. What do we have in E3? 1, 3, 5. So we have to cancel 1 and 3. The remaining term is what? 2. So this is the answer. So what about fifth one? If A is equal to a set of x such that 3 is less than x and s is less than 9, also x is an integer, and we'll just write down what is A. The set A is equal to x is greater than 3, 4, and also x is an integer 4, 5, 6, 7, and it is less than 9, so we have 8. So what about B? For set B we have B is set such of x such that 5 less than x and less than 12 and x is an integer. We'll have to write from 5, that is 6, 7, 8, 9, 10 and 11. Okay, so which of the following represents A union B? So we have A union B. So what do we have in A union B? We have all this numbers in set A, that is 4, 5, 6, 7, 8, and then we have 9, 10 and 11. All the terms in A and also all the terms in B. So which option is right? Option B. Moving on to activity 1.3. Consider an experiment of selecting a student randomly from a school where both boys and girls study. Let A be an event such that a 10th grade student is selected. Let B be an event that a boy student is selected. Are A and B disjoint? Okay, so we have a group of boys as well as girls, let's say. Okay, what is E? E is such that we have to select 10th grade student, right? So set A is X such that X is in 10th grade. You can write like this. Okay, so what is set B? Set B is nothing but B is the event that a boy student is selected. Let's say Y such that Y is a boy. Okay, so we have to find whether these two are disjoint sets. Let's say can we select a boy student here who is in 10th grade? Yes, we can select a boy in A. So can that same student be in this set? Yes, because he is a boy, right? So these two are not disjoint. What about second question? P is equal to 3, 8, 9, Q is equal to 9, 10 and 11. So we have two events, P and Q. Are they a disjoint event? That is the question. So we have to compare each term here. So we have 3. Do we have 3 here? No. Do we have 8? No. But we have a repeating term 9. So let's say if we draw the Venn diagram of this P and Q, let's say P and Q, at the intersection point we'll have the term 9. We have 3 and 8 here, and we'll have 10 and 11 here. So since we have a common element between these two sets, these are not disjoint event, right? Okay, third one, let A be is equal to 1 3 1 2 3 4 5 6 7 and B is equal to 6 comma 7 are two sets. The difference between set A and set B is given by, so the difference is nothing but elements containing in A but not in B, right? So we have to eliminate what terms? We have to eliminate 6 and 7 from A. That is nothing but 1 2 3 4 and 5. So this is the answer. What about next one? The sample space is given by 2 4 6 8 10 12 14 with sample space, and let A is equal to 2 4 6 be an event. The complement of A, let's say if this is our sample space, okay, and this will be the, let's say, set A, and this be the set A. What will be the complement of A? Complement of A is such that it belongs to S but not in A. That is nothing but all of this, right? So complement of A is nothing but universal set or sample space subtracted by A. So that is nothing but we have to subtract the elements of A from the universal set, that is 2 4 and 6. If we subtract 2 4 and 6, what is remaining? 8 10 12 and 14. 8 10 12 and 14 is the answer. Next one, consider the experiment of throwing a fair die. A is the event that an odd number is thrown. Let B denote the event of getting an even number other than 2. Okay, let's write down what are the different sets that are described here. What is the sample space? Sample space is nothing but we can get any number between 1 and 6, that is 1 2 3 4 5 and 6. What about set A? Set A is nothing but with the event that an odd number is thrown, that is 1 3 and 5. What about set B? Set B is nothing but even number other than 2, that is 4. What are the different even numbers? 2 4 6. Other than 2 is nothing but 4 and 6. Okay, what is, they have asked us to find out what is A union B. A union B is nothing but all the sets in A and B, that is 1 3 4 5 and 6. So this is the answer, option B. Moving on, Okay, consider a sample space S and three events A, B, and C as shown in the figure 1.4.1. Answer the following questions from the figure given below. Okay, so we have let's say three different sets. For the first question, we have which of the following regions represent A intersection B. Okay, so we have set A here, and we also have set B here. The A intersection B represents the region where we have two of these sets overlap. That is this one, right? So that is nothing but region 2 and 1. So that is region 1 and 2 is the answer. Okay, for the next one, which of the following region represents A intersection B and intersection C? Okay, we already know that A intersection B is what? This one. So what will be A intersection B and intersection C? And for this region, it has to be overlapped with C, that is only region 1. Only this region is the answer, that is region 1. Okay, for the next question, what do we have? We have A union B intersection C complement. Okay, so that is nothing but first one we have to get what is A union B. A union B is whole of this, right? What about C intersection? C intersection is all of the sample space except C, right? So what will be A union B intersection C complement? So this is A union B, and all of this is what? This is C complement, right? So all of this is C complement. So we have to find out what is A union B intersection C complement. It is nothing but this region. So that is nothing but region 7, region 2 as well as region 6. Region 2, region 6 and region 7. This is the answer.